Hello, in this lecture we'll find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two small circles. We know that the radius of this circle equals to B, the radius of this circle equals to A, and we also have the right triangle ABC that is partially located in the big circle. Angle ABC equals to 90 degrees. Side AB equals to 5 units in its length. Side BC equals to 12 units in its length. And we also know that AN equals to NC. And the right triangle ABC blocks this circle with radius A. Our mission is to find out the ratio between the two radii on the radius of this circle and the radius of this circle, or in other words, to find out the ratio of B over A. So first of all, we'll implement the Pythagoras theorem on the right triangle ABC. On the right triangle ABC, according to the Pythagoras theorem, by PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and it must be equals to AB squared plus BC squared. I'll repeat again. According to the Pythagoras theorem in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So if we found out that AC squared equals to 25 plus 144 is 169. AC squared equals to 169. We take out all of this equation and we get that AC equals to the square root of 169, that is 13. So the hypotenuse AC on this right triangle ABC equals to 13 units in its length, and because of the fact that AN equals to NC, it means that at point N the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So AC over 2, it is equals to 13 over 2. So the first half is AN and the second half is NC. So if I'm going to find out that AN equals to NC equals to 13 over 2. So you can write down here that the length of line segment NC is 13 over 2, that is the second half of the hypotenuse AC, that is equal to 13. Okay? So in the next step, I will present to you new rule number 8, and we will implement rule number 8 in our drawing. according to rule number 8, the radius of a circle that is blocked by a right triangle is equal R equals to A plus B minus C over 2. So here we have the right triangle ABC. Inside the right triangle ABC we have a circle. This circle is blocked by the right triangle. We know that the length of side AB is A, side BC equals to B incidence length, and the length of the hypotenuse AC is C. So according to this rule number 8, we can find out the radius of a circle that is blocked by a right triangle only by knowing the side lengths of the right triangle. That is to say, the radius of this circle R will be equal to A plus B minus C over 2. Okay, so we can implement rule number 8 in our drawing. Why? Because in our drawing we have the right triangle ABC. Inside the right triangle ABC we have this circle that is blocked by the right triangle. The radius of this circle is A. According to rule number 8, the radius A will be equal to AB, that is 5, plus BC, that is 12, minus the length of the hypotenuse AC, that is 13, over 2. Repeat again. According to rule number 8, the radius A of the circle that is blocked by the right triangle ABC equals to 15 plus 12 minus 5 plus 12 minus 13 over 2. 5 plus 12 is 17, so 17 minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. So we have found out that the radius A of the small circle is equal to 2 units. We can write down here that radius A equals to 2 units in its length. We define the center of this circle as P. We define the center of this circle as Q. AB, side AB is tangent to this circle, this point. We define the point of tendency as T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point of the circle itself. Therefore, PT is the radius of the circle that is equal to A, that is equal to 2 units. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent PT will be perpendicular. Then the radius PT will be perpendicular to tangent AB. So if AB is perpendicular to PP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. We define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2 units. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. So inside, on the other PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 470 degrees, plus the fourth angle. In total, they must be equal to 360 degrees. According to the rule, that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral with 360 degrees, the missing angle must be equal to 90 degrees. So inside quadrilateral TPBN we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TPBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say Pn equals to Tb, but Pn is 2, therefore Tb must be also equal to 2. Likewise, Tp equals to Bn, but Tp is 2, therefore Bn must be also equal to 2. So we found out that quadrilateral TPBN is not a rectangle but a square because all of its sides are equal to each other. So here it is given us an equation that AB equals to 5 units, and we just right now found that the TB equals to 2. AB minus TB equals to 80. Again, AB minus TB equals to 80. AB is 5, TB is 2, so 5 minus 2 is 3, so 80 equals to 3. From the current standpoint, point A, we have 2 tangents to this area, tangent AT and tangent AM, and according to rule number 2, they must be equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We already found out that AN equals to 13 over 2. AN equals to NP equals to 13 over 2. AM equals to 3, therefore AN minus AM equals to MN. Again, AN minus AM equals to MN. Repeat again. AN minus AM equals to MN. AN is 13 over 2 minus AM, that is 3, it is equal to MN. So we multiply 3 by 2 and we divide it by 2 and we get that 13 over 2, 3 times 2 is 6, so it is minus 6 over 2. 13 over 6 is 7, so in total this expression equals to 7 over 2. So we found out that Mn equals to 7 over 2. Mn equals to 7 over 2 units in its length. And this line segment Mn equals to 7 over 2 units. We define the center of the biggest circle as O. In the next step, I'll present to you rule number 7, and we'll implement rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisect a chord, then the line segment is perpendicular to the chord. The center of this circle is here at point O. We have the line segment ON, the line segment OM that is bisect chord AB. That is to say, OM divides AB into 2 halves. In other words, AM equals to MB. So we know that OM bisects chord AB because AM equals to MB. In that case, OM will be also perpendicular to AB. OM is perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. So we can actually implement rule number 7 in our drawing. Because in our drawing, from the center of the biggest circle, that is to say from point O, we join points O and then together by a straight line. Line segment ON bisect chord AC. Why? Because it is given us an equation that AN equals to NC. That is to say ON bisect AC. We know that from the center of the circle we have line segment that bisect a chord, like here, AN equals to NC, then line segment ON will be also perpendicular to chord AC. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees according to rule number 7. Okay, so we can write down that ON, according to rule number 7, line segment ON is perpendicular to chord AC. Q is the center of the circle. N is a point on the circle itself. Therefore, QN must be the radius of this circle that is equal to B. Again, QN is the radius of this circle. N is the point of tendency of tangent AC with this circle. The radius QN is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So we can write down that QN is also perpendicular to AC. Here we can write down that QN, radius QN, is also perpendicular to chord AC. And from these two equations, ON is perpendicular to AC and QN is perpendicular to AC, we derive that point O is located on the radius QN. Point O is located on the radius ON. Again, this is point O. Point O must be located on the radius QN. If point O is not located on the radius QN, then ON will not be perpendicular to AC. Therefore, point O must be located on QN, or QON is one straight line. QON is one straight line. QON is one straight line. Okay. At this point, this circle touches the bigger circle. We define the touching point as U. We go tangent to both circles, tangent with W. Yeah, tangent. This is tangent VW, that is tangent to both this circle and the bigger circle. Point U is the point of tendency with both those two circles. Okay. QU is the radius of this circle that is equal to B units in its length. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle, and whenever you have a radius that is drawn to point U, that is the point of tendency of tangent VW with the circle, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. So we can write down that QU is perpendicular to VW, QU is perpendicular to VW. In addition, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of a radius. Therefore, OU is the radius of the biggest circle. We define the radius of the biggest circle OU as x. So the radius OU is drawn to point O, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. Again, VW is perpendicular to UO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So OU is perpendicular to VW. OU is perpendicular to VW. So both QU and OU, they are both perpendicular to the same tangent, tangent VW. Therefore, you can derive from it that OQU is one straight line. OQU is one straight line. And segment OQU is one straight line. So OQU. So we can summarize and say that we found out that OQU is one straight line from one side, but we also found out that QON is one straight line. So this is a straight line and this is also a straight line. From those two statements, we will derive that QN is one straight line. If UQN is one straight line, then UN also must be a straight line. UN is a straight line that touches the circle at point U and N. Therefore, UN is a chord that passes for the center of the circle, that is to say for point Q. Any chord that passes for the center of the circle must be the diameter of the circle, therefore UN must be the diameter of the circle. So I can write down that UN is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius. And the radius of this circle equals 2b, therefore the diameter must be equal to 2b. So UN in total, we found out that UN equals to 2b. Okay? UN, this time when UN is the diameter of this circle, this to say is equals to 2b. In the next step, we join points P and O together by straight line. Point O is the center of the biggest circle. Point P is the center of the circle. We actually joined the center of the biggest circle with the center of the smallest circle by a straight line. This point is the touching point of the smallest circle with the biggest circle. We define the touching point as S. Again, at this point, this smallest circle touches the biggest circle. Point S is their touching point. In the next step, I will present to you rule number 9, and we will implement rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. Here, point O is the center of the big circle, point M is the center of the small circle. OM is the straight line that connects the centers together. According to this rule number 9, the straight line OM must pass through point P. That is to say, OMP is one straight line. Okay, OMP is one straight line. So we can implement rule number 9 in our drawing. Again, the smallest circle touches the biggest circle at point S. Point S is their touching point. OP is the straight line that connects the two centers together, and according to rule number 9, the straight line OP must pass through point S. That is to say, OPS is one straight line. So I write it down. OPS is one straight line. So if OPS is one straight line, here this OPS is one straight line, it means that PO must be equal to SO minus SP. Again, SO minus SP equals to PO. Why? Because OPS is one straight line. So SO minus SP equals to PO. So I write it down. SO minus SP equals to PO. Okay. You should remember that if SPO is a straight line, then SO must be also a straight line. What is the definition of the straight line SO? Point O is the center of the biggest circle. Point S is the point of the biggest circle itself. This is exactly the definition of a radius. So SO is the radius of the biggest circle that is equal to x. So here we substitute SO in this equation by x minus SP. Here we already found out that SP is the radius of this circle that is equal to 2. So we can substitute SP in this equation by 2. So in conclusion, we found out that PO equals to x minus 2. Write it down again, that PO equals to x minus 2 units in its length. Okay. PO equals to x minus 2. In the next step, we will extend the perpendicular ON by straight line ON is the perpendicular of the straight line, and when we extended the straight line ON by straight line, the result must be a straight line. Okay, so here ONT must be a straight line. So if you focus on this side of the straight line ONT, if you focus on this side of the straight line OT at point N, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of ONT at point N? We have this angle that is equal to 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. Okay. It is given us the question that tangent AC is tangent to this circle at point M. We'll join points P and M together by a straight line. Point P is the center of the circle, point M is the point on the circle itself. So this is exactly the definition of a radius. So PM is the radius of this circle that is equal to 2 units. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC must be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees. And this angle equals to 90 degrees also according to rule number 1. Okay, in the next step, we'll do a construction. We will draw perpendicular on the radius MP at point P exactly. Okay, we'll draw perpendicular on the radius MP at point P. So, actually, this angle equals to 90 degrees according to our construction. So inside quadrilateral NTP NM NMPT, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees plus the missing angle in total must be equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So inside quadrilateral MNPT, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral MNPT as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, PM equals to TN. But PM is 2, therefore TN must be also equal to 2. We define the length of line segment NO as H. In rectangle MNPT, MN must be equal to PT according to the rule that the opposite sides of a rectangle are equal to each other. But MN is 7 over 2. Therefore, PT must be also equal to 7 over 2. Okay. So in the next step, we'll implement the Pythagoras theorem on the right triangle POT. Repeat again. We'll implement the Pythagoras theorem on the right triangle POT. According to the Pythagoras theorem, on the right triangle POT, PO square is equals to PT square plus TO square. Repeat again. According to the Pythagoras theorem, in the right green triangle POT, PO square equals to PT square plus TO square. We have already found out that PO equals to x minus 2, therefore PO square must be equal to x minus 2 square. So PO square is x minus 2 square. That is equal to PT square. PT equals to 7 over 2, therefore PT square is 7 over 2 square. Plus TO square. Here, TO in total equals to Tn plus NO, that is to say TO equals to Tn, that is 2, plus NO, that is H. So in total TO equals to 2 plus H. If TO equals to 2 plus H, it means that TO square equals to 2 plus H square. Here we open the brackets on both sides of the equation and you get that x minus 2 square equals to x square plus 2 square, that is 4, minus 4x, and it's equal to 7 over 2 square. 7 over 2 square equals to 49 over 4, plus 2 plus h square. 2 plus h square equals to 2 square, that is 4, plus h squared plus 4h. Okay. In the next step, we join points O and C together by a straight line. So what is the definition of line segment OC? Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of the circle, the biggest circle, is equal to x. Or n equals to h, and we already found out that nc equals to 13 over 2. So I copy the right angle ONC in the new page, and we implement the Pythagoras theorem on this right angle ONC. So actually, this is the right angle ONC that I copied from the original domain. Again, ON equals to h, NC equals to 13 over 2, and the hypotenuse OC equals to x, according to the Pythagoras theorem. X squared equals to h squared plus 13 over 2 squared. 13 over 2 squared equals to 13 squared, that is 169 over 2 squared, that is 4. So in total we found out that x squared equals to h squared plus 69 over 4. In the next step we'll substitute x squared here by h squared plus 169 over 4. We'll do it now and we'll get that. So x squared is h squared plus 169 over 4 plus 4 minus 4x, and it is equals to 49 over 4 plus 4 plus h squared plus 4h. So this is the equation that we got after substitute x squared by h squared plus 169 over 4. So here we have h squared on both sides of the equation, so h squared will get cancelled. And we have also 4 on both sides of the equation, so 4 also will get cancelled. And we're left only with 169 over 4 minus 4x, that is equal to 49 over 4 plus 4h. Here we'll add 4x to this equation and we get that 169 over 4 equals to 49 over 4 plus 4x plus 4h. Here we subtract 49 over 4 from this equation and we get that 169 over 4 minus 49 over 4 equals to 4x plus 4h. Here we take 4 as a common factor from this equation, and inside the brackets we left only with x plus h. So in conclusion, we found out that 169 over 49 is 120, so it is in total this expression equals to 120 over 4. That is equal to 4 times x plus h. So here 120 over 4 is 30, so 30 equals to 4 times x plus h. Here we divide this equation by 2 and we get that 40 times 2 is 15. Is equal to 4 over 2 is 2. 2 times x plus h. So here we divide this equation by 2 and finally we get that x plus h equals to 15 over 2. So we actually found out that x plus h equals to 15 over 2. So what is the value of un? Un equals to uo plus on. That is to say un equals to uo, that is x, this is the radius of the biggest circle, plus on, that is h. So in total un equals to x plus h. Again, un equals to x plus h. So you can find out that un equals to x plus h. But we have already found out that un also equals to 2b. It is the diameter of the circle. So we can write down that un also equals to 2b. And from those two equations un equals to x plus h and un equals to 2b, we derive that x plus h equals to 2b. So I write it down. X plus h equals to 2b. Again, x plus h equals to 2b. X plus h equals to 2b. But we already found out that x plus h equals also 15 over 2. So you can write down here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we will derive that 15 over 2 equals to 2b. 15 over 2 equals to 2b. Here we divide this equation by 2 and finally we get that b equals to 15 over 2 over 2 is 15 over 4. Found out that b equals to 15 over 4, that is to say the radius of this circle B equals to 15 over 4 units in its length. And we already found out that the radius of the small circle A equals to 2 units. So what is the value, what is the ratio, the value of B over A? B is 15 over 4 over A, that is 2. So 15 over 4 over 2 is 15 over 8. That is to say we found out that B over A equals to either 15 over 8 units, or in terms of numbers it is equal to 1.875. And that is the answer to the question. The ratio between the 2 and the I, the radius of this circle and the radius of this circle, that is to say B over 8 is equals to either 15 over 8 units, or in terms of numbers it is equal to 1.875 units. Okay, in the next step I will summarize the lecture. So in this lecture we found out the ratio between the radius of this circle and the radius of the small circle. And the radius of this circle is B and the radius of this circle is A, so found out the ratio of B over A. In the drawing we have a big circle. Inside the big circle we have those two small circles. In addition, we have inside the big circle the right triangle ABC that is partially located inside the big circle. This angle ABC equals to 90 degrees in its length, side AB equals to 5 units in its length, side BC equals to 12 units in its length. And we also know that AN equals to NC. Our mission is to find out the ratio of B over A, that is the ratio between the radii of those two circles. So first of all, we implemented the Pythagoras theorem on this right triangle ABC. According to the Pythagoras theorem, AC square equals to AB square plus BC square. In the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. That is to say, AC square equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. So in conclusion, we found out that AC square equals to 25 plus 124, plus 144. 25 plus 144 is 169. So AC square equals to 169. We took out of this equation and finally found out that the square root of 169 is 13, so AC equals to 13 units in its length. That is to say, the hypotenuse AC of the right triangle ABC equals to 13 units in its length. But we also know that AN is equal to NC. That is to say, at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So AC over 2 is the two halves. So the first half AN is 13 over 2 and the second half NC is also 13 over 2. So AN equals to NC. Those two halves, of course, equals to each other. Each half equals to 13 over 2. AN equals to NC equals to 13 over 2. Then I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, if a line segment is drawn from the center of a circle, bisect a chord, then the line segment is perpendicular to the chord. Point O is the center of this circle. We have chord AB inside the circle. OM, that is from the center of the circle, line segment OM from the center of the circle, bisect chord AB. That is to say, AM equals to MB. So whenever you have from the center of a circle, in this case it's point O, any line segment that bisects a chord, like in this case OM bisect chord AB, then OM will be also perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 7. We can implement rule number 7 in our drawing. Actually, it is rule number 7. So we can implement rule number 7 in our drawing. Actually, it is rule number 8. It is rule number 8. It is a different rule. Rule number 8 states that the radius of a circle that is blocked by a right triangle R equals to A plus B minus C over 2. Here we have the right triangle ABC. Angle ABC equals to 90 degrees. The length of side AB is a unit, side BC equals to B units in the left, and the length of the hypotenuse AC is C. The center of the circle is at point O. The radius is R. According to rule number 8, you can find out the radius of a circle that is blocked by a right triangle only by knowing the side lengths of the right triangle that blocks the circle. That is to say, the radius of this circle R will be equal to A plus B minus C over 2. Okay, so we can implement rule number 8 in our drawing. In our drawing, we have the right triangle ABC that blocks the circle. The radius of this circle is A. So you can find out the radius of this circle A according to rule number 8. A, according to rule number 8, must be equal to AB plus BC minus AC over 2. Again, A equals to AB plus BC minus AC over 2. Okay, so A, the radius A equals to AB, that is 5, minus BC, that is 12. Again, A equals to AB, that is 5, plus BC, that is 12, minus AC, the hypotenuse, that is 13, over 2. Repeat again. According to rule number 8, in the right triangle ABC, the radius of the circle that is blocked by the right triangle ABC will be equal to A, that is 5, plus 12, BC is 12, minus the hypotenuse, that is 13, over 2. 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So in conclusion, found out that the length of the hypotenuse A is 2. Here, the hypotenuse A, the length of the radius. The length of the radius of the circle A is 2. A equals to 2 units in its length. Okay. In the next step, we define the center of this circle as P. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of this circle, point T is the point of the circle itself, therefore PT is the radius of this circle, that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 1. We define the point of tendency of tangent BC with this circle as M. We join points P and N together by a straight line. Pn is the radius of this circle, that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees, this angle equals to 90 degrees. This is according to rule number 1. So in quadrilateral PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the missing angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in quadrilateral PTBN to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral PTBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be a rectangle or flat square. So when we relate to quadrilateral PTBN, it's a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to TB. But Pn is 2, therefore TB must be also equal to 2. Likewise, in the rectangle PTBN, PT must be equal to Bn. but PT is 2, therefore Pn must be also equal to 2. So actually found out that all the sides of quadrilateral TPBN are equal to each other, therefore quadrilateral PTBN is a square. What is the length of AT? From the law it is very easy to see that AT equals to AB minus TB. Again, AB minus TB equals to AT. AB is 5, TB is 2, so 5 minus 2 is 3. So AT equals to 3. Then from the common external point, point A, we have two tangents to this circle, tangent AT and tangent AM, and according to rule number 2, they are equal to each other. That is to say AT equals to AM, but AT is 3, therefore AM is also, must be also equal to 3. Then we know that AN equals to 13 over 2. AM equals to 3. Therefore MN must be equal to AN minus AM. Again, AN minus AM equals to MN. Repeat again. AN minus AM equals to MN. AN is 13 over 2, MA is 3. 13 over 2 minus 3 is equals to 7 over 2. So we found out finally that Mn, this line segment Mn equals to 7 over 2 units in its length. Then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if a line segment is drawn from the center of a circle, if a line segment that is drawn from the center of the circle bisects the chord, then the line segment is perpendicular to the chord. The center of the circle is at this point, point O. We have chord AB. The line segment from the center of the circle, that is to say line segment OM bisects chord AB. That is to say AM equals to MB. And therefore, whenever you have a line segment from the center of the circle that bisects the chord, then the line segment must be also perpendicular to the chord. That is to say OM equals to OM is perpendicular to AB. OM is perpendicular to MB. We can implement rule number 7 in our drawing. Why? Because in our drawing we define the center of the biggest circle as O. The center of the biggest circle we define it as O. From point O we join points O and N together by a straight line. ON bisects chord AC. Again, ON bisects chord AC. Why? Because AN equals to NC. So ON bisects chord AC. And therefore, according to rule number 7, ON that bisects chord AC must be also perpendicular to chord AC. So ON is perpendicular to AC. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees. According to rule number 7, so I can write down here that ON is perpendicular to AC. According to rule number 7, point Q is the center of this circle. Point N is the point on the circle itself. Therefore, Qn is the radius of this circle that is equal to B. Units in its length. AC is tangent to this circle, point N. Point N is the point of tendency. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC must be perpendicular to the radius NO. If AC is perpendicular to NO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. This is actually according to rule number 1. Rule number 1, according to rule number 1, QN is perpendicular to AC, and according to rule number 7, ON is also perpendicular to AC. From those two equations, we will derive that point O must be located on Qn. This is point O, that it must lie on this line segment Qn. Otherwise, if point O doesn't lie on Qn, then ON will never be perpendicular to AC. Therefore, point O must lie on Qn. Line segment Qn. Again, point O is located on Qn. That is to say, QON is one straight line. Again, QON is one straight line. This is one straight line. QON is one straight line. This point, in this point, this circle touches the biggest circle. This is the touching point of the biggest circle with this circle. We define the touching point as U, and then we draw tangent VW, that is tangent to both circles at point U. Again, tangent VW, tangent to both circles at point U. Okay. So point Q is the center of this circle. Point U is the point of the circle itself. This is exactly the definition of a radius. So QU is the radius of this circle. We have the radius QU that is drawn to point U. That is the point of tendency of tangent VW with the circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees, according to rule number 1. So you can write down that QU, the radius QU, is perpendicular to VW, to tangent VW. Point O is the center of the biggest circle. Point U is the point of the biggest circle itself. This is exactly the definition of the radius. Therefore, OU is the radius of the biggest circle that we define as X. The radius OU of the biggest circle is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, that is to say it is drawn to point U, that is the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So OU is perpendicular to VW, rule number 1, and QU is also perpendicular to VW according to rule number 1 also. From these two equations, QU is perpendicular to VW and OU is perpendicular to VW, we will derive that OQU is one straight line. OQU is one straight line. Again, OQU is one straight line. Okay, here, OQU is one straight line. So we found out that OQU is one straight line. But we already found out that QUN is also one straight line. And from the fact that OQU is one straight line and QON is also one straight line, from those two statements, we derive that in total NQU is one straight line. NQU is one straight line. So NQU is one straight line. If NQU is one straight line, it means that NU is also a straight line. NU is a straight line that touches this circle at point N and point U. Therefore, NU is a chord. NU is a chord that passes through the center of this circle. That is to say, it passes through point Q, that is the center of the circle. And then any chord that passes through the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. NU is the diameter of the circle. And UN is the diameter of the circle. And the diameter of any circle is twice as long as the radius, and the radius is b, therefore the diameter un must be equal to 2b. So we actually found out in conclusion that un equals to 2b. un equals to 2b. Okay. In the next step, we joined points O and P together by a straight line. Point O is the center of the biggest circle. Point P is the center of the circle. So we joined the two centers together by a straight line. The smallest circle touches the biggest circle at this point. This is their touching point. Actually presented to you rule number 9, and we implemented rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. Here, the center of the big circle is point O, the center of the small circle is point M. OM is the straight line that connects the centers together. According to this rule number 9, the straight line OM that connects the centers together must pass for point P. That is to say, OMP is one straight line. Again, OMP is one straight line. You can implement rule number 9 in our drawing. Why? Because in our drawing, we have OP that connects the center of the biggest circle with the center of the smallest circle. Those two circles have an internal arch between them at point S. That is to say, they are touching each other internally at point S. Therefore, according to rule number 9, the straight line OP that connects their centers together must pass for point S. That is to say, OPS is one straight line. I'll repeat again. OPS is one straight line. If OPS is one straight line, it means that OS minus SP equals to PO. Again, SO minus SP equals to PO. SO minus SP equals to PO. Repeat again. SO minus SP equals to PO. I remind you that SPO is one straight line. If SPO is one straight line, then SO must be also a straight line. SO is also a straight line. What is the definition of the straight line SO? The straight line SO starts from the center of the biggest circle and ends at the point of the biggest circle itself. Therefore, SO must be the radius of the biggest circle that is equal to x. Therefore, we can substitute SO by x minus SP. We already found out that SP is the radius of this small circle that is equal to 2 units. So we can substitute SP by 2. So we can find out that PO equals to x minus 2. PO equals to x minus 2. Then we extended the perpendicular ON by a straight line. So when you extend the straight line by straight line, the result is a straight line. So OT must be a straight line. If you focus on this side of the straight line, OT is point N. Here the sum of the areas must be equal to 180 degrees, according to the rule that the sum of the areas from one side of the straight line is equal to 180 degrees. So which angles we have at this side of 48 point N, we have this angle that is equal to 90 degrees plus the missing angle, they must be equal to 180 degrees according to the rule that I mentioned. So so the missing angle here must be equal to 90 degrees. This angle equals to 90 degrees. We also know that AC is perpendicular, AC is tangent to this circle, point M. Point M is the point of tendency. We joined point P and M together by a straight line. Point P is the center of this circle, point M is the point of the circle itself. Therefore, PM is the radius of this circle that is equal to 2. the radius PM is drawn to point M, that is the point of tendency of tangent AC with this second. And whenever you have a radius that is drawn to the point of tendency, then tangent AC must be perpendicular to the radius MP. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Okay, so we found out that this angle equals to 90 degrees, this angle equals to 90 degrees. The next step, we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So here, this angle equals to 90 degrees according to our construction. We find the touching point of the perpendicular and the extended ON as T. So inside quadrilateral MNPT, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. So inside quadrilateral MNPT, we have 4 right angles. Any quadrilateral that has 4 right angles must be this rectangle is not a square. So when we get to quadrilateral MNPT, it's a rectangle. We know that the opposite sides of a rectangle are equal to each other. That is to say, MP equals to NT. But MP is 2, therefore NT must be also equal to 2. Therefore, in addition, actually, in rectangle MNPT, we also know that MN equals to PT, but MN is 7 over 2, therefore PT must be also equals to 7 over 2. Then we implemented the Pythagoras theorem on the right green triangle OPT. On the right green triangle OPT, according to the Pythagoras theorem, OP square equals to PT square plus TO square. I repeat again, in the right triangle POT, PO square equals to PT square plus TO square. PO equals to x over 2. If PO equals to x over 2, then PO square must be equal to x minus 2 square. And it is equal to PT. PT is 7 over 2, therefore PT square is 7 over 2 square, plus TO square. TO is Tn plus NO. That is to say, TO is Tn, that is 2, plus NO, that is H. In total, TO equals to 2 plus H. So TO square equals to 2 plus H square. We opened the brackets on both sides of the equation and found out that x minus 2 square equals to x square plus 4 minus 4x, and it is equal to 7 over 2 square. 7 over 2 square equals to 49 over 4, plus 2 plus h square equals to 2 square, that is 4 plus h square, plus 4h. Then we joined points O and C together by a straight line. We focused on the right triangle O and C. What is the definition of the straight line OC? Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. This is exactly the definition of a radius. OC is the radius of the biggest circle, that is equal to x. ON equals to h according to our definition. And we already found out in the beginning of the lecture that NC equals to 13 over 2. It is half of the hypotenuse AC is equal to 13. Therefore it is 13 over 2. So ON equals to H, NC equals to 13 over 2, and the hypotenuse OC equals to x. According to the Pythagoras theorem, x squared equals to h squared plus 13 over 2 squared. So x squared equals to h squared plus 13 over 2 squared equals to 13 squared, that is 169 over 2 squared, that is 4. So in total we found out that x squared equals to h squared plus 169 over 4. So we can substitute x squared in this equation by h squared plus 169 over 4. So we did it and found out that here x squared equals to h squared plus 169 over 4 plus 4 minus 4x equals to 49 over 4 plus 4 plus h squared plus 4h. Here we have h squared on both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled. And we left only with 169 minus 4x, this is equal to 49 over 4 plus 4h. We added 4x for this equation, and found out that 169 over 4 equals to 49 over 4 plus 4x plus 4h. Then we subtracted 49 over 4 from this equation and found out that 169 over 4 minus 49 over 4 equals to, here we took 4 as a common factor from those two expressions, so inside the brackets we left with x plus h. 169 minus 49, it is 120, so in total this expression equals to 120 over 4, that is equal to 4 times x plus h. 120 over 4 is 30, so 30 equals to 4 times x plus h. We divided this equation by 2 and found out that 30 over 2 is 15, so 15 equals to 2 times x plus h. Then we divided this equation also by 2 and found out finally that x plus h equals to 15 over 2. X plus h equals to 15 over 2. But from this drawing, it's very easy to see that un equals to uo plus on. That is to say, un equals to uo, that is x, that is the radius of the biggest circle, minus on, that is h. So in total, un equals to x plus h. So we can write here that un equals to x plus h from one side. But from the other side, we have already found out that un equals to 2b. It is the diameter of the circle. So you can write here that un equals to 2b. And from these two equations, un equals to x plus h and un equals to 2b, we will derive, of course, that 2b equals to x plus h. 2b equals to x plus h. Equals to x plus h. But we have already found out that x plus h is also equals to 15 over 2. So you can write here that x plus h equals to 15 over 2, and from this equation 15 over 2 equals to x plus h equals to 2b, we will derive that 2b equals to 15 over 2. 2b equals to 15 over 2, we divided this equation by 2 and finally found out that b equals to 15 over 2 is 15 over 4. So the radius b of this circle equals to 15 over 4 units in its length. We already found out that the radius a of the small circle equals to 2 units in its length. So b equals to 15 over 4 and a equals to 2. So what is the ratio b over a? B over a equals to b, that is 15 over 4, over 8, that is 2. 15 over 4 over 2 is 15 over 8. So we actually found out that the ratio b over a equals either to 15 over 8, or in terms of numbers, it is equal to 1.875 without units. Okay, so the ratio b over a, that is the ratio between the two radii of this circle and this circle, equals to either 15 over 8 units, or in terms of numbers, it is equal to 1.875. Okay, thank you very much.